Okay, everyone. Let's continue on to section 2.3, spread of a contagious disease. And before we get started on it, let me talk about something which you haven't talked about explicitly yet. Suppose you have dy dt is equal to, let's just say, 3y. Okay? So the rate of increase, and now I'm talking about the rate of increase with respect to time. That's why I'm using a t there, is I'm talking about t time being in seconds or minutes or hours or days or years or millennia or something or another. So so the rate of increase is proportional to how much is there. If you have okay, so whatever amount is there, you multiply that by 3, and that gives you the rate of increase. And so if we go through the steps, I won't go through all these steps. I'll just do it very quickly here. We're going to get dy over y is equal to 3 dt. Integrate both sides. You're going to get absolute. You're going to get log the ln of the absolute value of y is equal to 3t plus c, and then you get absolute value of y is equal to e to the 3t times e to the c. And then you take the plus or negative of that, and you get y is equal to a times e to the 3t. And if you were to sketch that out, say a is equal to, well, let's just put it right there. Oh, let's make it a little bit smaller. Say right there. Then a e to the 3t is going to look something like this. It's going to be your exponential increase like that. On the other hand, if you had dy dt is equal to negative 3y, then you go through these same steps and you're going to get y is equal to a times e to the negative 3t. Agreed? Just replace the 3 with a negative 3 all the way through. And if you graph that, I'm going to start with a higher value here for a, because now as time goes on, what happens to your function? It looks like that. So if this here is a positive number, then you get exponential increase. If it's a negative number, you get exponential decrease. Okay? By the way, if that were equal to 0, then it's saying that the derivative is 0, which means the function isn't changing at all, which means it's just going to stay horizontal. It's going to stay constant like that. Okay? So let's well, I got them all here. I'll just mark them all. A is greater than 0, a is equal to 0, and a is less than 0. Okay? So what's key about an exponential function is that, as I say, the rate of increase is proportional to how much is there. In other words, if you think about this graph, the higher the graph is, that tells you the rate of increase, right? You take the value of the graph and you multiply it by 3, and you're going to get the slope of it. Here you take the value of the graph. Okay, here's the value of the graph right here, and you multiply that by negative 3, and negative 3 is of course going to give you a negative number, and that's going to give you a negative slope. So notice here that the slope is a large negative number. Why is it a larger negative number? Because y is larger, and so this is larger, which means the slope is a larger negative number, which means you're going down at a fast rate. Once you get over here, now the value of y is smaller, and so even though this is negative, it's a small negative number, which means that the slope is a small negative number, which means you're still decreasing, but you're decreasing at a smaller rate. See that? So it just goes down like that. This, of course, is just the opposite. As you go out here, y increases. As y increases, the rate increases. So this is why exponential functions are so powerful, because they're whatever they do to the extreme. Whatever they do to the extreme. It's very seldom that you get an a is equal to 0. So either something is going to die out, and if it dies out, it's going to die out all the way to 0. If you take this function, the limit of it, as t goes to infinity, it's just going to head to 0 pretty fast. On the other hand, if this is a positive number, then it's going to blow up really fast. And so that all ties in to section 2.3, which is the spread of diseases. So let's see once what we have here. So reading from the textbook here, I say, suppose you've got yourself a disease, something like COVID, for example, and let's let y of t be the number of people sick with the disease, whatever it is. Okay? And I'm kind of letting t be like 2-week periods. So every 2 weeks we take our new measurement. So we can kind of think of this as little increments of 2 weeks, but we're still going to think of it as a continuous differential equation. And so we've got some initial number of people that are sick. So y of 0 is equal to a. So there's your initial number who are sick right there. And now, what does the book say? Suppose that on average, every person gives it to beta other people during the week, and then they get better themselves. So in a 2-week period, each person passes it on to beta number of people, and they get better. Okay, so kind of roughly it looks something like this. The rate of increase, if you think of it as kind of being like increments of 2 weeks, the rate of increase is each person is going to give it to beta number of people. Each of these people who are sick are going to give it to this many people. So that's the rate of increase. Each person here, however many people are sick, each one of those is going to give it to this many people. So you multiply those together, and there's the amount of increase. But then the person themselves get better. Okay, so they're no longer sick. So you can subtract one off like that. Okay, so that's the idea. So you end up with something like that. And if you solve this differential equation, just like we solved the other ones, you're going to get something like this. Y of t, and you go through the details here, but you're going to get, it's going to end up being a, there's your initial amount, e, and here's your constant, beta minus 1 times t. And so now you can see that, first of all, if every single person just gave it to one other person in that 2-week period, if they gave it to one other person and they themselves got better, then what's going to happen? Then the number of people who are sick is just going to stay the same. Agreed? Everyone is giving it to one person and they're getting better. So in this case, if beta is equal to 1, then 1 minus 1 is 0. E to the 0t is 1, and so you're just going to stay at a. You're going to stay at a right there. If beta is greater than 1, if you're giving it to, on average, more than one person over that 2-week period when you're sick, then this is going to be a positive number. And what did we say happens when you take e to a positive number? It's going to blow up exponentially. It's going to go up like that. And that's just the start of it. It's going to go way up. Okay? So this is when beta is greater than 1. And finally, if beta is less than 1, so beta is, you have to give it has to be some positive number. So maybe it's between 0 and 1 now. If it's between 0 and 1, so you give it either to 0 people or you give it to maybe a half a person on average. Then what? Then when you subtract 1 from it, this is now going to be a negative number, and you're going to get exponential decrease. And so that explains why it's so important during this whole COVID thing that we're living through even yet, to have a sense of how many people are getting it from the others. And so you've heard, at least in the early days of COVID, they wanted to get that multiplier effect down less than 1. Because if it's greater than 1, that means that it's going to be going like this. If it's less than 1, it's going to be going like that. And if you read what I have in the book there, I say, well, different strategies are meant by different countries were meant to either get it down less than 1 or not. And in the U.S., we didn't, because U.S. we have just lots of people that are very strong on their own rights and freedoms, and don't want to change their behavior necessarily for the benefit of their neighbors. And so they don't get vaccinated, don't wear masks, things like that. And so on average, this is what happens. And right now we are in a crisis with hospitals and things like that, because there's lots of people that are sick and dying and everything else because of that. On the other hand, if you're in a country where either people in the country have kind of learned from example that they're part of this community and they have to act in concert with the others, or maybe they're forced to because of the laws of the country, then they stay masked up and vaccinated and things like that. Then people on average give it to less than 1 person, and look at what happens. So anyway, that's all been very important stuff over those last couple of years as we've looked at COVID. So that's section 2.3. I'll let you take it from there.